Welcome everyone. Today I will be presenting our final year project, hybrid AI interview coach and adaptive framework for interview training using RAG and real-time speech processing. I will first like to thank our guide, Mrs. Kusum ma'am, for her esteemed insights on our project, and also thank my group members for their contributions. Problem statement. Current interview preparation systems are largely generic and non-adaptive. They fail to assess a candidate's true technical depth and communication ability. Most platforms do not consider the candidate's background, do not track learning over time, and provide only superficial feedback. This creates a need of a system that can dynamically adapt, evaluate deeply, and provide continuous and personalized improvement. Our methodology follows an end-to-end adaptive pipeline that integrates resume understanding, knowledge retrieval, real-time interaction, and intelligent evaluation. Initially, the user's resume is processed through a dual pipeline where an LLM extracts structured information such as skills and experience, while the same text is chunked and embedded into a FAISS vector database for retrieval. A unified RAG layer then leverages both resume and technical knowledge to generate context-aware questions and corresponding expected answers, ensuring that all interactions are grounded and relevant. During the interview, an adaptive engine controls the flow by selecting topics, tracking concept level mastery, and dynamically adjusting difficulty, subtopics, and follow-up questions based on users' performance. Simultaneously, user response are captured through real-time speech processing, where audio is transcribed and analyzed for communication communication metrics like fluency and pauses. Finally, the system performs a multimodal evaluation by combining semantic similarity, keyword coverage, concept detection, and speech analysis, updating the user's mastery profile and generating a comprehensive feedback report with actionable insights for improvement. Our proposed architecture. So, from the architecture perspective, the system begins with the user logging in and selecting either a resume-based or an adaptive interview from the dashboard, while all user data and session information is managed in a SQLite database. In the resume flow, the user uploads the resume, which is which is processed using PyPDF parsers, then chunked and converted into embeddings using sentence transformers, and stored in a FAISS vector database. Simultaneously, an LLM extracts structured information to enable personalization. During the interview, a unified RAG pipeline retrieves relevant resume or technical content and uses the LLM to generate grounded questions and expected answers. In the adaptive technical flow, uh, our adaptive interview, the, the adaptive controller initializes the session, selects topic, and follow up based on the mastery using a rule-based decision engine. Questions are delivered via text-to-speech, and user responses are captured through WebSocket streaming, where an audio fork mechanism sends data to AssemblyAI API for real-time transcription while also extracting speech metrics like pauses and fluency. The transcript response is evaluated using semantic similarity, keyword coverage, and concept detection, after which mastery is updated and the next action is decided. This continuous loops run until the session ends, and finally the system aggregates all performance metrics to generate a comprehensive feedback report.
Demo, and first we will start by logging in. Okay, so then we have our resume analysis and mock interview. Here we upload a resume and then we can paste a job description. After this, our system analyzes the resume and finds how fit our resume is for the job description. It extracts uh, important sections of the resume such as experience, project skills, and certificates. You can see them here. And this is our job fit. So we can start a resume based interview.
Hi there. Thanks for joining me today. Could you please introduce yourself and tell me a bit about your background?
Hello, good morning. My name is Pranav, and currently I'm pursuing my bachelor's in artificial intelligence and data science from Vivekananda Education Society Institute of Technology. Uh, so I enjoy this course because it helps me understand how modern AI system works. It helps build the foundations for multiple AI systems as well. I have also done multiple projects. Thank you.
Your resume mentions skills like Python, SQL, HTML. Can you tell me about your experience with these technologies?
So mostly I've used these languages to mainly build projects. Python I've learned from my coursework, and I've used it in multiple places. Most importantly, in machine learning, and also some backend projects I have developed using it. SQL is mostly used for database querying, and I have mastered MySQL language. HTML I've used mostly for designing the front-end structure to understand how to place the text or images on the screen.
I see you work on Survey Mage. Could you walk me through your role and the
And this is our analysis of the interview. We can start with a new interview or go back. Then we have a mock interview, adaptive interview.
How does a thread within a process share memory with other threads? And what are the implications of this sharing compared to separate processes?
Okay, so a thread within a process. So threads are mostly a basic unit of a process. Uh, all threads see the same virtual memory address space. If one thread writes to a global variable or dynamically allocated memory, other threads can immediately read that change. So in modern operating system, threads within the same processor share the same process memory. So sharing memory via threads is efficient but dangerous without proper synchronization.
How does the overhead of context switching differ between processes and threads? And what underlying mechanisms cause this difference?
Okay, context switching. So the overhead of context switching is significantly lower for threads within the same process than for separate processes. The key difference is that within the same process, context switching cost is low, while in separate processes, the context switch overhead is high. In the same process, CPU registers, program pointer, stack pointer, these all states are need to be saved. In separate processes, everything CPU registers, program pointer, stack pointer, plus the memory management unit, state plus page tables and TLD flash needs to be saved in memory. Process switch. So most
How does the relationship between processes and threads in multi-threading enable efficient resource sharing while maintaining isolation? And what trade-offs arise from this design?
okay. So uh, the uh, the process level. So each process has its own virtual address space, file descriptors, signal handlers, and security context. This prevents one process from corrupting or snooping on another. While thread level process threads within a process share all these process level resources but have private stack and register context. This allows them to work on the same data without inter-process communication overhead. So this results in a controlled sharing inside a process and strong isolation between processes. So some of the trade-offs are security versus performance. Threads are fast but lack isolation. A bug in one thread compromises the whole process. Complexity of synchronization. Shared memory means you must use mutexes, semaphores, atomics. This introduces deadlock, live lock, and priority inversion risk. Bugs that don't exist in isolated processes using message passing.
How would you differentiate between encapsulation?
So we can see our speech metrics at the end and content quality as well. We can also see the question, the user answer, and the expected answer. This helps the user understand how to answer a question, what keywords to include, where he is lacking. The speech metrics allows user to understand like how much time he was speaking, like if he was going slow or fast, words per minute, articulation rate, as well as hesitation. So this is a full technical feedback of the user. And finally, we have profile management where we store all the interview history of the user. You can see here.